First problem that we're going to work, we already have a graph. So we're going to be answering a lot of questions from the graph. Notice this is, we're talking about a small rocket, and it has right now the height, h, in feet of a small rocket, t for seconds, that's our time, after it is launched. And the path of the rocket is given by the equation h equals negative 16t squared plus 128t. Now, negative 16t squared, there's your lead coefficient. You know it's going to be a frowny face. So if I took this marker and I hummed it at Mason, right here, bam. So it went up in the air and it lobs down. Why is it coming down?
Because gravity.
Gravity is going to make it come down. So it's not going to stay in the air. We've learned that from science. So that is why all of our equations, ladies, the graphs are going to all be frowny faces. Because gravity is going to make, if it goes up, it's got to come down. And notice in this case, it's a negative 16 as the lead coefficient. You're going to see that a lot in our problems because there are equations that deal with gravity, and that's part of the gravitational equation. But we're not going to get into all of that today. So, in looking at this, how long is the rocket in the air?
428 seconds.
Do what?
I didn't see that.
What?
4 seconds.
8 seconds.
Oh, yeah, 8.
All right, why? I don't know if it was Francis. I heard somebody back in there. 8 seconds. How did you come up with that?
Because I looked on the graph. It had the dot.
Oh, it was Lexi. Okay, the dot. It stopped over
that
there
makes sense.
at 8, right here.
Oh.
It stopped. Where did it start?
It started
0.
It started at 0, which would
0.
make sense because it had to leave somewhere. And it stopped 8 seconds later.
This is actually pretty easy.
Yeah.
I promise it's not. Some of the questions you're going to have to think a minute, but they're going to make sense. Okay? Now, what is the greatest height the rocket reaches?
250.
260.
I think it's about 260.
Or
It's,
like 259.
yeah, somewhere about there.
Yeah, 259.
Now, what do we call this dot up here?
Oh my,
Point of origin.
The AOS.
oh my gosh.
vertex.
The vertex.
Oh.
Thank you. I know now Mason can breathe. The vertex. And it is our highest, or if it were a happy face, our lowest point. So when they're talking about maximum height, we are looking for the y component of the vertex. Okay? The x will tell us how long it takes the y to get up there. So if it's the highest point it's going to reach is 260 feet, how long did it take that to happen?
4 seconds.
4 seconds. You look down here, here's our dot, trace that on down, and it came to 4 seconds. So technically, our vertex would be 260. All right. About how high is the rocket after 1 second?
100.
100.
It's going to be, somewhere about.
190.
Notice the word right there. It'll be about, and if we go up from 1,
190.
it's going to cross, not quite. No, because see, here's 150. 110, 15, somewhere, 105, somewhere in there. I'll put about. It's going to be ish, though, 100 feet. All right, after 2 seconds, we're going to travel up. About, where are we in 2 seconds?
190.
We'll say about 190 feet. Is that going up or down?
That's going up.
Up. About how high is the rocket after 6 seconds?
190.
They're kind of the same thing.
190. About. And it's now going down. So you notice and we actually have dots for the 2 and 6 seconds. And they're not quite to the vertex yet, and then they hit the vertex and they start coming back down. So, do you think the rocket is traveling faster from 0 to 1 second or from 3 to 4 seconds?
0 to 1.
0 to 1.
Why do you say that?
Because it went from 0 all the way to 190 in
Ye-
2 seconds.
Yes, but then from 3 to 4, I mean, we're traveling like from this dot right here to this dot. We barely,
It's like very short.
very, and then it's starting back over. So definitely
0 to 1.
the 0 to 1. And I think you understand, I'm not going to write down our reasoning, but I think you see that there's a huge jump, and then there's just kind of a little bit of movement from the 3 to 4. So it says, using the equation, find the exact value of the height of the rocket at 2 seconds. What information are we given in this?
The exact value.
There's a dot at 190.
But what are we being given?
Feet.
We're told one more little thing. What?
About the height of
2
the rocket.
seconds.
The 2 seconds. That's our time. So where does that go in the equation?
Your x.
It would be our x, but what are they using for x?
T.
T. So you're going to grab this equation. I'm going to rewrite it down here. H equals negative 16t squared plus 128t. Come on. Oh my goodness.
Mason, can you skip this one just a little bit? Thank you.
There. All right, so we're going to take that 2 and we're going to plug it in everywhere we have a T. And we're going to get the height. So what did you get for the actual height? Remember to square the 2 before multiplying by negative 16. Or you can go in the calculator and say negative 16 times 2 squared plus 128 times 2. What'd you get?
192.
192 feet.
Oh,
Excellent. Do what?
I put in 16 times 2 squared. I put plus 128 times 2 squared.
Oh, no, don't square it the second time. Silly goose. All right. A ball, so for number 8, a ball is thrown in the air. The path of the ball is represented by this equation. Graph the equation over the interval. 0 is less than or equal to t. What's t?
1.
What's t representing? Time. Time. Look, and y'all, time is always your x-axis. Always, always, always. Whether it's days of the week, months, years, seconds, decades, anything. So we have 2 intervals. We have 0, and then t is also less than or equal to 8. So do you see those are going to be the 2 numbers we plot on the x-axis. I'm going to mark my x-axis like they did in the first equation, making a mark every other line so I can spread it out. So here is 0, and then I have a mark here, 2, 3, 4, 5,
Are you doing a line
6,
between each one?
7. I'm skipping it so that it's not so cluttered. It's too small when I try to do them side by side, so I spread it out so it's easier to see. Now when I make the y-axis mark, I'm going to do every one because that's the number we're going to get will go off the board if I do every other one. So it says, what is the maximum height of the ball? What are we trying to find if we're finding maximum height?
How high it went?
Yes, but what is maximum height going to be? The vertex. Is it the x or the y of the vertex?
Y.
The y. So what do we have to find first to be able to find the y?
Yes.
And what do we use to do that?
Opposite A over.
Opposite
Opposite
b
A
over
A
2a. That thing. All right.
That.
So -8, that's our opposite b, over what?
2 negative 4.
2 times negative
Two.
1.
So -2, which gives us what number?
Positive 4.
4. Positive 4. 1, 2, 3, 4. So here's our 4. And I'm just going to write a 4 down below it. All right. That's just the x value, or our t value. That's the time when our maximum height will be reached. But what is the maximum height? Go plug it in.
Oh, now.
What? So we'll have height, because that's what we're looking for, equals -2, I'm sorry, whoops, I was looking at it, 4,
16.
yes, 4 squared plus 8 times 4. And you should have gotten 16. So that's 16 feet. Nope, 16 meters, my bad. So I'm counting every one because we don't have 32 little marks. So 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. Run over there. All right. There's our graph at the vertex. So, the next question. How long is the ball above 7 meters? Meters, what is that? What is meters referencing?
The height.
The height. So, we have a variable for height, which is what?
Meters. Oh, sorry.
What variable do we use for height?
H.
The h. So we're going to take our 7 and replace the h with it, because height is the meters. So 7 equals. And then we put what?
H.
That's our 7. The h is the 7.
16.
The equation.
Wait, negative.
Negative t squared plus 8t. Okay? We're still using that top equation.
Are you factoring?
We've just we're going to, yes. We are going to factor because we're wanting to know, to get a value. All right? So, what do we do with the 7 now?
You move it over.
Move it over, which means what are we replacing the 7 with? 0. 0 equals negative t squared plus 8t minus 7. Okay, if we're wanting to factor, one more change we have to make.
Make the negative t positive.
Woohoo! Make the negative t positive.
So flip the whole thing.
So we're going to have plus t squared minus 8t plus 7. Okay? Which means two factors that equal 7. When we add them, it'll be 8.
1 and 7.
1 and 7. But what signs will we use inside the binomials? Positive or negative?
Positive.
Nope, because we have
B negative.
negative 8. So negative, negative, and we do 7 and 1. Is y'all remembering this part about factoring?
Yes.
Then, so what does t equal?
7. C equals
7.
positive 7 and then positive 1.
All right. So the time, t, time,
7 seconds.
7 and 1, that's when it's going to be at 7 meters. So I'm going to go over here and I'm going to go 1, 2, 3, 4, 5, 6, 7. And I'm going to go plot a dot here. And I'm going to run over here and plot a dot there. Now, my question, though, is not at what seconds was the ball at 7 meters. It's above 7 meters. How long did it take to get to 7 meters in the beginning?
4 seconds. 1 second.
1 second. Okay? And then it stayed above 7 meters and it got all the way to the vertex of 16 meters and it started trekking back. How long did it take to get to
2 seconds.
the vertex?
2 seconds.
3.
Right?
3.
Because
From, wait.
From 0?
from 0 or
4.
All right, it took us 1 second to get up to the 7 meters, right? That's kind of our starting point.
So 3.
So how long? It took us 3.
Oh,
And then to come back, staying above 7, how long did it take?
3.
So how many seconds were we up there?
6.
6. All right, so I'm going to show you one more thing too. 6 seconds. God, that looks like a wild looking 6. I don't know what was wrong with it. Had a curly Q. Okay, it's also subtracting. You found the time it was up there. 1 second and it's 7 seconds. 7 minus 1, 6 will give you the time that it was above the 7 seconds. Okay? Does that make sense? All right. It's still not too crazy hard. Now we have no graphs. So, T, things to remember. T is representing what? I mean, is it's time. And what axis is it representing? The X. H or D is what or distance? Height. And it's representing which axis?
Y.
The Y. All right, we're going to have times when we're sitting at 0. And that's going to be referencing a height for ground. So if we're standing on the ground to toss something up, we're standing at 0. If we're at the water level, like in a boat, we're at the height of 0. And it's telling you right here, when an object hits the ground or water, its height is 0. So, let's get started. Oh, do y'all remember when we had equations back in the day? This would have been back like
8th.
long time. Still, well, we did this last year, but we also did it first semester. If I said y equals 3x
Oh, yeah.
plus 2, and I said, what's the value for y? Do you remember how to find that out?
Oh,
What'd you do? Just y.
You subtracted
Plug in
Which is
0.
supposed to be.
You plug in 0.
You made what?
You plug in 0
And for what variable?
for X.
For x. So what is y?
2.
2. You could like cover up. So y is 2.
So it's like the
And then if I needed to know what the x happened to be, you would cover up the y, but solve for the 2. So we would cover up the y, and we would have negative 2 equals 3x.
And then it would be 3.
X equals negative 2/3. Y'all remember doing this? So we're going to have a little bit of memory lane on that, just ever so slightly. All right. Erase, 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 erase. So we have this ball that's tossed in the air. After leaving the ground, what height was the ground?
Oh,
0.
0. Okay. And we are using this equation to show the path that it is following. Tell me about that equation. What's wrong with it? What do we need to do to be able to use it?
Around, because
We need what to come first?
the square.
The square. Excellent. And the reason I'm being toothy with it, it needs to come around, is because when you're grabbing the opposite b, I don't want you to grab negative 16 and make it a positive. All right? So what we're going to do is rewrite it. H equals negative 16 t squared plus 144t. Whoops. And notice if I ask you what is the height, you can cover up all of that. And what's out here?
0.
Plus 0. And that's really also, it's telling you we're at ground level. Okay? So that you know we're starting there. Alrighty. What is the height of the ball after 3 seconds? How do you figure that out?
You plug the 3 in for the T.
Plug the 3 in for the T. It's seconds, time. Replace the time with the 3. You are so smarticus. -6, sir.
Weren't we supposed to get our clothes back today?
Well, not right now. -16 times 3 squared plus 144 times 3. So work that and tell me what you got for the height of the ball after 3 seconds. So what's our height?
288.
Yep.
288 feet. So, here we go. What is the maximum height the ball will reach?
288.
Right? No.
No, that's the height of the ball after 3 seconds. Maximum height means we got to have what?
You have to.
Oh, you have to do the thing you just did.
Yeah, it's just vertex.
Vertex. You're finding vertex. Opposite B over 2A to get the X, or your T value. Plug the T back in to get your H value, which is the Y, which is how high up there it is. Giddy up. What is your X, or if you will, the T value?
No.
T is 3. Right?
No, that was that
144?
question.
144?
Well, opposite B is what? What's our B?
0.
No, that's C. What is B?
B is -16.
That's our A.
144.
Y'all, that's why I said you have to rewrite. You can't use that. It's not in standard form. That's why we rewrote it over here.
That's 6.
So,
I got a decimal.
144.
I got 4.5.
Divided by.
what is B?
144.
So opposite B, -144. What's A?
-16.
So -32. You should have gotten what Sarah Jane said a minute ago, 4.5. So then you take 4.5. That's your X value. That's how many seconds it's going to take for it to reach vertex, maximum height. Now plug it in.
So plug it into H. Wait, H equals negative.
We're finding the height. Mm-hmm. So how high up will it eventually travel?
324.
324 feet.
324 feet. So, are we good with that question? All right. Then for C, find the number of seconds the ball is in the air when it reaches a height of 224. A height. What letter is height?
H.
So what are we going to replace height with?
224.
224.
Do we keep the X and the like 4.5? Do we?
We're on another problem. We put the t, we're looking for seconds. So we don't have a seconds. The 4.5 is a second. We're back to the original equation. So we'll have, whoops. Negative 16t squared plus 144t. Now, if we're trying to find this out, we're trying to solve, seconds is which axis?
X.
X.
The x. So to find out, to solve for the x, we need to be able to factor, which means we need to make the equation equal what? 0. So that means the 224 is going to move over as a,
0.
no, negative. So negative 16t squared plus 144t minus 224. To factor, though, what does the lead coefficient need to be? Has to be positive. So that means all of the signs change. So plus 16t squared minus 144t and plus 224. So what is the first thing? Those are some big numbers. So what, though, was the very first thing that I told y'all to always ask before you factor? GCF. All right, huge hint.
4.
When you're working, no ma'am, we're going to be glad it's not.
16.
We are hoping to have a lead coefficient of 1. That would make it so much easier. So check and see if 16 will go into both of the numbers. It does. So I'm going to remove a 16. And we're going to be left with t squared minus what?
Minus 9,
Plus what?
14.
14. Good. So two factors that equal 14 that when we add, we get 9.
Oh. Wait, 7.
Yes. So will we have a negative inside of our binomials or a positive inside?
Negative.
Negative, because we have negative 9t. So t minus 2, t minus 7. But then we need to know what the solution, we need to solve those. So what does t equal?
Positive 7.
And positive 2.
And positive 2. 2 and 7. Now let's go back and look and see what the question asked. Find the number of seconds the ball is in the air when it reaches a height of 224. So we're starting at ground zero,
And 7.
and at 2 seconds, it's going to be 224. It's going to keep traveling. It's going to get to the vertex, and then it's going to flip, and it's 7 seconds. On the way down, it'll be at 224 again. So you do have 2 answers for this. One's on the way up, while the other's on the way down. It's kind of cool. All right. Next question. After how many seconds? Seconds is your X or your Y?
Your Y. Oh, I know your X.
X. Will the ball hit the ground before the rebound?
Is
We're
the ground like it bounces up again?
Yes. So it's going to go up in the air and it's going to go boom and it's going to bounce for you to go chasing after it. So that means we're going to take our equation and we're solving it, right? Like we would do, we make it equal instead of H. What are we going to make it equal? 0. So 0 equals negative 16t squared plus 144t. We need what to happen before we can solve?
It needs to be positive.
Needs to be positive. So we have a positive 16 and a negative 144. What is the GCF?
16.
T.
Good. 16t. And we're left with t minus what?
9.
9. So then we solve. Make each of your factors equal 0.
16t.
So 16t equals 0 gives us what number?
16.
Nope.
Oh, no, t equals 0.
T equals 0. Excellent. And then t minus 9?
Positive
T equals 9. All right. This works because we start, if you're going to throw a ball, the ball is actually at 0. So that's the starting point. It's going to travel up, 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 and it's going to land when? 9 seconds later for somebody to go chase the ball. So the final answer really would be your 9 seconds. This is the starting point. Are y'all good?
Nick Gage.
I think we'll stop.
Wait, really?
Yay.
Yes.